So 5.6 related rates, worked out problems. Quasar, surface of a sphere, right equation relates ds dt to dr dt. So simple enough. Ds dt, only one variable, constant, equals 8, 2 times 4 is 8, pi r dr dt. Radius, right side of v equals pi r squared r. How is dv dt related to dh dt if r is a constant? Well, I like these problems. They're making you think a little bit. So in that case, when v equals pi r squared times h, dv dt, r is a constant, equals pi r squared dh dt. If h is a constant, dv dt equals 2 pi r h dr dt. Yep. And if neither is a constant, then we got a little product rule action. So v equals pi r squared h. dv dt equals, leave it, pi r squared dh dt plus derivative 2 pi r h dr dt. Showing some mad calculus skills there. Definitely want to get good at that. A and B are the lengths to the triangle. Yeah, no kidding. This looks fun. So I believe what they're getting at is this. If I recall from my algebra 2 days, put a theta here, and an A here, and a B here, and bring a dotted line down here. This dotted line is sine is opposite over hypotenuse, sine is height over theta, A times sine of theta. So this is A sine of theta, and the area will be 1/2 base times A sine of theta, but hey, I got to put it alphabetical because I'm a nerd. Cool. All right. Big nasty here. dA dt, because we have 3 variables. dA dt equals where was I? dA dt equals, I'm going to leave the 1/2 out front. And product rule with 3 things, you leave 2 constants and 2 as constant and derivative of the other one. So I'll take the derivative of A, B sine of theta, dA dt, plus A sine of theta, dB dt, plus, I'm going to bring it down here because I'm running out of space, AB cosine of theta, d theta dt. Yeah, that's correct. Circular plate of metals, heat in an oven, its radius increases. dr dt is 0.01 centimeters per second. How about area? Let's relate area and circle. And then take the derivative with respect to t. dA dt, 2 pi. Everything's in centimeters, no conversions. 50, 0.01 equals, if I'm not mistaken, pi centimeters squared per second. Careful with the units, but they usually work out. Closed rectangular box changing, right to the volume, surface area and diagonal length. Instance, wow, that's a lot of work. The volume is x times y times z. So just like we did before, dv dt equals y z times dx dt plus xz times dy dt plus xy times dz dt, which equals 6 times 1. Yeah, I'm just blasting this out. Plus 8 times -2 plus 12 times 1, which equals, and this is cubic meters per second. Yep. Not really clear on units here. Should say meters. We can make that assumption with the meters per second up there. We get 2 cubic meters per second. Surface area is 2xy plus 2yz plus 2xz. dsa dt is monster. 2x dy dt plus 2y dx dt. This is going to give me a headache. Plus 2y dz dt plus 2z dy dt plus 2x dz dt plus 2z dx dt. Lots of product rule, which equals -16 plus 6 plus 6 plus -8 plus 8 plus 4, which equals 0 meters squared per second, which is weird. Cancel. 460. Yeah, cancel. There it is. And diagonal. Oh, they gave it to me. That was nice of them. So ds dt equals 1/2 square root of x squared plus y squared plus z squared times 2x dx dt plus 2y dy dt plus 2z dz dt, which equals 8 times 1 plus 6 times -2 plus 4 times 1 over 2 times the square root of 16 plus 9 plus 4 equals 0, which is very weird. Things are changing, but they're changing at a rate that they all cancel each other out. Spherical balloon, V equals 4/3 pi r to the third. Should probably write that down. Inflated how fast is balloon's radius increasing when r equals 5 feet? dv dt equals 4 pi r squared dr dt. 100 equals 4 pi 25 dr dt. dr dt equals 4 times 25 is 100, so just 1 over pi. Oh, wait, there's a pi in there too. That's 100 pi, my bad. 100 pi. So yeah, they all cancel out. We get 1, what are we looking at? Foot per minute. How fast surface area increasing at that instant? Well, SA equals 4 pi r squared. DSA dt equals 8 pi r dr dt. DSA dt equals 8 pi times 5 times 1 equals 40 pi feet squared per minute. Child flies a kite at a height of 300 feet. One carries a kite horizontally. How far must a child let the string out when the kite is 500 feet away? I don't like these because it's a little confusing as to what the hypotenuse is, but we'll do the best we can. So here's your kid. Kite. If I'm reading this right, stayed at 300 feet. That's a constant. Okay. And then it's moving sideways here, and it's 500 feet here. Which means this is 400 feet because it's a 3, 4, 5, and I'm leaving my units off. We'll go with y. I'm just trying to string out when the kite is 500 feet away. So I'm very confused by this. Oh, how fast. I read far. All right. How fast must the string be out? This is your x. This is your z. So dx dt we're given is 25. I'll put the units in on this one to be a little thorough. Feet per sec. And they want to know dz dt. X squared plus y squared equals z squared. 2x dx dt plus 2y dy dt. It stays at a constant height, so that's a 0. 2z dz dt. So dz dt equals feet per second. So it'll be feet per second. Let's see if I can do this in my head. 1,000, 4 times 25 is 100. It's an extra 0 there. So 20. Hey, I got it. 20 feet per second. Sand falls from a conveyor belt, rate of dv/dt. Conical pile. So looking at this, height of the pile is always 3/8 of the base diameter. Cool. Got some work to do here. dv/dt we know 10 cubic meters per minute. The pile is 4 meters high. All right, so let's do that part first. Height is 4. 4 equals 3d over 8. 8 times 4 is 32. D equals 32 thirds. So the radius is 16 thirds. Okay. Volume is 1/3 pi r squared times h. Now, there's a few different ways to do this. I think I will go with h equals 3/8 times 2r. That's the height and radius changing. He wants them both. It's kind of a hassle. 2, 4. So I'll go with the r first. R equals 4h/3. So the volume is 1/3 pi 4h/3 squared times h. dv dt equals, as h to the third, that's 16/9. So it's 16 pi over 9 times 3h squared dh dt. dv dt equals 10. I'm running out of space, so I'm going to kind of slap this together. 10, h equals 4, 16. It's going to get ugly. Yeah, I got to get the calculator out. So 10 times 3 divided by parentheses 16 times 16 times pi, 0.037. That seems wrong, so now I got to pause things. Yeah, it was off the screen for a while there because I made a mistake here. So this is actually 3 squared is 9 times 3 is 27. And then we cross that out and we get 9, 3, and 27. So never make shortcuts. That's the lesson of the day. 10 equals 4 squared is 16 times 16. 256 pi over 9 dh dt. dh dt equals 10 times 9 divided by 256 times pi. 0.1110906. Why all the decimals? You'll see times 100 because we want it in centimeters equals 11.191. Height centimeters per minute. The units of time are still the same. Minute, yes. Which doesn't leave us a lot of room here, but we can cheat. We know that r equals 4h d theta, therefore d theta. Anyway, dr dt equals 4/3 dh dt. So that's dh dt. Keep that same number in the calculator, times 4 divided by 3. And that is dr dt equals 14.921 centimeters per minute. Sorry for making a hash of that one. Onwards, water is flowing at the rate of 6 cubic, yada, yada. Volume, they gave it to us. Oh, isn't that delightful? What rate is the water level changing when water is 8 meters deep? So dv dt equals 6, which equals some messy stuff here. Pi over 3, a little trouble with the handwriting all of a sudden. Y squared times -1 plus 2y times 3r minus y. Three times 13 minus y. dy dt. Now dy dt actually went on both terms, but I just factored it out to make life easy. So I'll multiply out this 3 times 6 and bring the pi down, equals negative 64 plus 2 times 8 is 16, 39 minus 8, 31 times 16, 496 dy dt. Watch our units, dy dt equals 0.013 meters per minute. What is the radius r of the water surface and water y meters deep? So there's that triangle right there. I'm going to redraw it. R 13. The radius of this entire thing is 13. This distance is 13 minus y. R squared plus 13 minus y squared equals 13 squared. R equals square root of 13 squared minus 13 minus y squared. So R we can write as square root. We can blast this out here. This is actually 169 minus 26y plus y squared. So the 169's cancel, negative, negative, so we get 26y minus y squared. So now, of course, I want to take a derivative of that, which is why it was nice to get it much simpler. dr dt equals 1 over 2 square root of that, 26y minus y squared, times 26 minus 2y. dy dt, again, I'm factoring that out, equals 8. What am I doing there? 2 times 8 is 16. Confused again. So a little bit of an issue here. Up here, we're looking at the change in volume, and we have to be really careful here. If I solve this with the pi in it, I'd get 1 over 24 pi. Now, what rate is the water level changing? Water level's going down. So I need to squeak a negative in here somewhere. And I don't see where it's happening. So it's a little upsetting to me. We'll leave it there for now and not worry about it. The change in y, the change in y is 0.013. So water's flowing at the rate from a reservoir. So y is going down. So it's really negative, even though I don't see it anywhere in here. I don't like that, but sorry, we're stuck with it. So here we get 26 minus 16, 10. Multiply 8 and 8 squared, square root and 2. We get 24. And then we'll go up here and take this negative 1 over 24 because the radius is changing negative. Now, if you had left it off on both problems, that's fine, as long as you're aware of what's going on. So that gives you negative 5 over 288 pi. That's in meters per minute. Or if you're a person who really likes to see that, decimal 0.006 meters per minute. All right. That's the radius is getting, again, if you look at this, it's going down, the radius is shrinking, not getting bigger. I think if we're going to figure out where that negative popped out, we're gonna have to say it's flowing out at a negative rate. So actually we'd probably put a negative here and a negative here, and that would solve all our problems. All right, anyway, twice I've had a pause in this video. This is the type of problem you'll see on an AP exam. 30-foot ladders and against a house, X, Y, Z. Base starts to slide away when the base is 12 feet away. The base is moving at the rate of whatever. This is 13 feet, so therefore this is 5 feet, A squared, B squared, C squared. How fast is the ladder sliding down the wall at that moment? So this is an X squared plus Y squared equals Z squared. Notice the Z is constant, doesn't change. So when I do this, I'm going to shortcut a little bit. 2x dx dt plus 2y. That's so weird. 2y dy dt equals 0. 24. And what's going on here? Time basis when that is moving. Base is moving times 5 plus 2 times 5 times 2y dt equals 0. So dy dt blasted out negative 12 feet per second, which makes sense. It's heading down the wall. What rate is the area of the triangle formed by the ladder, wall, and ground changing at that moment? So area is 1/2 xy, and dAdt, leave the 1/2 out front, is leave it dy dt plus leave it dx dt, which is 5 times 5 plus 12 times negative 12, which equals 25 minus 144 over 2, negative 100, and 19 over 2 feet squared per second. And what rate is the angle between the line and the ground changing at that moment? So let's redraw our triangle. Gonna have to go with tangent because the things that are moving are in the tangent world. So for future reference, cosine is adjacent over hypotenuse, secant is 13 over 12. Why did I do that? You'll see. Tangent of theta equals y over x. Secant squared theta d theta dt equals low d high minus high d low over low squared. Secant squared theta is 13 squared, so we're looking at 169 over 144 times d theta dt is 12 times negative 12 minus 5 times 5. I see that a lot over 12 squared. Cancel, cancel, divide by 169. D theta dt equals, bizarrely enough, negative 169 or 169, negative 1 radian per second. Particle moves along the parabola, y equals x squared in the first quadrant, that is x coordinate, increasing at a constant rate How fast the angle of inclination of the line, join the particle of the origin, changing when x equals 3. I feel like I'm going to need this point. Well, that's an x. That's a y. That's a theta. Tangent of theta equals x over y. Y equals x squared. Tangent, of theta equals x over x squared equals x to the negative first. Secant squared theta d theta over dt equals -1 x to the second dx dt. Now let's do some math here. X coordinate 10, got it. X, got it. Secant squared, don't got it. So let's see what's going on here. 3, definitely not drawn to scale. 9, just found a mistake in my old notes. 81 and 9, square root of 90. I am not going to break that down at this time. So cosine is adjacent, therefore secant of theta is root 90 over 3. I actually can reduce that, so I lied that I wasn't going to reduce it. I might as well. So root 10 squared is 10 d theta dt equals 1 over 9 times 10 d theta dt equals I'm confused what I did wrong. I found a mistake here. Okay, let's see if I'm right or if my old note is right. I think I'm right. I got my X in the wrong spot, don't I? And I fixed it down here. Up here, this should not be a Y. X, Y, right? 3 squared 9, yeah. I drew it horribly so I could see the angle. Huh, interesting. It's like very simple, -1/9 radians per second. My old answer said -1 radians per second. I didn't even say -1. How fast is the angle of inclination? Doesn't say speed here, otherwise I'd have to change that to +1/9. No, that's it. All right, lots of math. Good luck and happy mathing.